Okay, in this last part 3 video, we're going to be talking about if-then statements. Now, we see these all the time in mathematics. For example, if you have two negatives, then it turns positive. Notice there was like a natural progression there. So with if-then statements, we call them conditional statements. All right? So we're just going to go right into this. The compound statement, if P, then Q, is denoted as P with an arrow to the right, Q. This is called our conditional statement. And if you think about it, the word conditional means you have to meet a condition, which is that if part. Now, the if part of this statement has a name. So the letter P is called the antecedent. And then the Q is called the consequent. So like I said, you have to meet a condition first. And if you met that condition, then you do this result. All right? So a really simple example of this would be, if it is cold outside, then I will wear a coat. So notice the condition has to be met first. The condition is cold outside. So if I deem that is cold outside, then I will wear a coat. I forgot the word A. All right? So that is how this works with an if-then statement. All right? Now, like I said, you see this all the time in mathematics, all the time. If I think we've all seen this before, it's called the distributive property. All right. And this distributive property looks like this, where what you do is you take this letter A, whatever it happens to be, and you multiply it to every single term inside of the parentheses. Now, this is the way, if you were to look it up, this is the way it would look. You can Google this. Distributive property, that's the way it's going to look. All right? But what you could write here if you wanted to is this. If you have a number outside of a grouping of parentheses, then you would multiply each term inside of the parentheses by the number outside. Bingo. There's your if-then statement in mathematics. Okay? So let's look at an example, just trying to use if-then statements. So we're going to write in symbolic form. Using the antecedent and the consequent. All right, we're going to do two examples. First one, we're going to say P equals P will be if I am driving. Q will be, actually, we'll just say P is I am driving. Q would be using turn signals. That's always important. So if I wanted to write if P, then Q, well, all I have to write is just P with that arrow, Q. And what this is telling me is I am driving, or I'm sorry, if I am driving, then I'm using turn signals. It's exactly what that is saying. P, if P, then Q. The second example, though, is kind of interesting because this is an equivalent way to express if P, then Q. And that would be if not Q, then not P. So if you reverse the order, if you make the consequent the antecedent and the antecedent the consequent, if you reverse them and negate them, so that's the key here, reverse and negate, then listen to how that statement above sounds. If I am not using my turn signals, then I am not driving. So that is an equivalent expression to if P, then Q. Because it's saying the same exact thing. It's saying, hey, if I'm not using my turn signals, then you know I'm not driving. However, on the flip side, if I am driving, then I am using my turn signals. So this gives you a little insight into how my day went today. Somebody was driving and they didn't use their turn signals properly, and I got a little upset. So that's why I'm still thinking about it. But anyways, we're going to close up this section in the last video, and it's going to bring everything together: the and statement, the or statement, the if-then statement. We're going to learn one more called the biconditional, and we're going to learn how to write all these things. So that'll be in the next video.